welcome to our webinar presentation on the topic of inside the wheel bearing, how what happens at the factory changes what happens in the bays. My name is Jim Merle. I'm group publisher at Babcock's Media and the moderator for this event. The sponsor of today's webinar is BCA Bearings by NTN, a product developed specifically for the automotive aftermarket. In this webinar, we will examine a wheel bearing starting with raw materials, its design, its engineering, and the impact it has on the wheel bearing that you are replacing on your customer's vehicle. So now I'd like to introduce our presenter. We're happy to have Andrew Markell joining us today. Andrew is the Director of Content for Brake and Front End, Import Car, and Underhood Service. He's been with Babcock's Media for nearly 20 years. He's a former tech, service writer, and service manager with experience at independent shops and dealerships. Andrew is also an ASE certified automotive tech. I'd also like to introduce experts from NTN's Automotive Aftermarket Division, BCA Bearings. Joining us is Mark Gorski, he's Manager of Product Management. Mark Tarrant is joining us. He's the Application Engineer. And Divjo Singh, also an Application Engineer. BCA Bearings are NTN's product line developed specifically for the automotive aftermarket. Andrew, take it away.
Thank you, Jim. Well, as they say in the bearing business, let's get rolling. The goals for this webinar, most of all, we're going to understand the different wheel bearing types and how they apply to different vehicles. We're also going to get into learning about the manufacturing process, which is kind of critical because you're installing an awful lot of wheel bearings, it seems like lately. We're going to go into the basic components. We're going to look at the materials, the components, and most of all, the manufacturing tolerances. Kind of give you a different perspective on bearings that you may not have had before. And again, we're going to take this knowledge that we've gained on metal, tolerances, the different components, and we're going to apply it to make you better able to inspect the bearing, troubleshoot a wheel bearing problem, and even select the right wheel bearing for the vehicle. So let's get going. I just want to add this one thing here. Jim touched on this. We've got the experts from NTN with us. So ask your questions as they occur. Type them into the box, and we're going to try to answer them live this time because we've got the experts right here. So ask away, please. So the first thing I'd like to talk about is the application and understanding the application and why bearings are different. There's no one bearing for any vehicle, size-wise and diameter. It's a balancing act. So they're looking at the static load of the vehicle. How much does it weigh? They're looking at the track of the vehicle. How wide are the tires apart? They're also looking at the rolling radius of the wheels and tires. How big is it? Determining how fast the bearing will have to turn at certain speeds. And again, how loud will that bearing be? And they'll sort of dictate maybe even the bearing diameter and the types of bearing rolling elements that will be used. And most of all is the center of gravity of the vehicle. Is it a pickup truck? Is it a sports car? This will determine the overall sizing of the bearing and the rigidity of it. So let's talk about the basic internals. Ball bearings. These are the most important ones out there, most commonly used on light vehicles because they have less drag, they're highly efficient, and they're good for high-speed applications. Tapered roller bearings. These are designed for higher loads, but they're more noisy and they have greater rolling resistance. So an engineer will look at what the vehicle is, how much it weighs, the capabilities of the vehicle, and what the OEM is requiring from it, and decide between these typical two designs. Next, packaging. This is a big criteria because there's only so much space behind the wheel because you're fitting in the brakes, the suspension in that area, in the corner of the vehicle. Is the wheel going to be driven by an axle? Is it going to just turn on its own? Those are critical things to take into account. And most of all, the brake system. How rigid does that flange have to be in terms of how big is the rotor? Will it change, knock back the pistons in the caliper? That's always a consideration too. But the OEMs, they're looking for fuel efficiency. This could be on a pickup truck. This could be on a light vehicle. And they're looking for the best possible combination of load, longevity, and efficiency for that application. Okay, let's go into the materials. We're kind of covering right now in this area what is starting in the manufacturing process and the design. And now we're starting to get into the manufacturing side of this presentation. There is not just one type of steel. There are different types of steel that go into a wheel bearing. And a wheel bearing in the hub unit, it can differ. I mean, it differs on the amount of carbon in it and a couple different factors. But what they're kind of engineering around is the hardness of the steel and making sure that the hardness of the steel matches the requirements. And another thing to really keep in mind, highly engineered polymers for the cages that keep the rolling elements properly spaced, and also the seals. This has probably been the greatest area of advancement for a lot of wheel bearings, and it's kind of the reason why wheel bearings are lasting so long lately. But unfortunately, you can't see these things. You can't determine by pulling this out of the box. You have to trust your manufacturer, your brand, your supplier to make sure that you're getting a high quality component. Okay, this is sort of where we kind of get to a little bit of the science here. Clean steel. The enemy of all steel out there in wheel bearings is inclusions. And these are typically non-metallic, and it's left behind after the smelting process. But the better the smelting process, the better processing the steel, the fewer the inclusions. And this is what a engineer is looking at when they start deciding, is the steel good enough for a wheel bearing? And what they're looking at is the size, the quantity, and even the shape of the inclusions to determine if it's a high quality steel that can be used for a rolling component. Because these inclusions create weak spots in the steel. And these will help to get fatigue started, which causes an accelerated wear rate, fracturing, and cracking of the component in some cases. Okay, here's another kind of neat thing I didn't even realize about wheel bearings. And we're kind of going to get a little, almost electron microscope here. Actually, electron microscope. Forging. You know, the races and the balls are forged. And this is a process that uses heat and pressure. Kind of the blacksmith way to do it. But wheel bearings, it's highly scientific and highly engineered. The forging, well, it changes the grain structure of the raw components of the steel. And it helps to improve the strength and the hardness of the balls and raceway. And this grain structure, kind of like a little bit like wood. And typically what's happening is when you start forging a component into the shape of, let's say, a raceway or a ball bearing, you're unifying that grain structure.
Hey, Andrew, hit the pause button for a moment. We have a
okay.
You asked for questions to be submitted, and I think that's a great approach for today on today's subject matter. Questions are rolling in, and we just received one from Robert, and he's asking, how does the grain structure differ in cast or stamped parts?
Hi, this is Mark Tarrant, application engineer with NTN, and I just wanted to interject and answer this one. So the long story short is a cast part doesn't have a grain structure. It doesn't have a grain flow. It's just a homogeneous mixture of the steel, and there's no actual grain structure. When you're dealing with a forged part, for example, since it's forged from a billet where there is like a linear grain structure, it allows you to essentially control the form of the grain structure, so you can reinforce something like a flange, whereas something in a casting doesn't have that, which also is why a casting would be potentially weaker when dealing with any type of impact or any loading.
Great information, Mark.
Thanks, Mark. Appreciate that answer.
Okay, let's move on to something in the same realm here, the heat treating or case hardening of certain components in a wheel bearing. What this does is it helps to actually improve those microstructures inside the steel itself. And this improves the strength and durability of the overall wheel bearing hub unit. A lot of the components on a wheel bearing, they're going to be heat treated. But the next step up, which is actually a form of heat treating, is case hardening. And this is typically done to the races and rolling elements to further improve the durability of the surfaces. This is a very involved process that it just can't be rushed, because if that case hardening goes too deep, you actually make a part more brittle. But if you go too shallow, it can actually lead to premature wear, and the likelihood that, let's say a curb strike or something similar will cause a mark in the raceway of the bearing and cause issues with wear that could possibly cause noise and require replacement. But the optimal depth, it's a balance between hardness and durability. And this is case hardening, and what it does for the wheel bearing. It makes that wheel bearing last a lot longer. And the manufacturer, it's very involved because it requires a lot of energy and time. Energy means keeping the bearing at a certain temperature, controlling the environment that the bearing is being heat treated in, and most of all, it's about knowing the product going into that heat treating or case hardening process. You can't go in there because it's not going to solve problems with inclusions or other things with the forging itself. So, very complex process, and it needs a lot of control to pull off case hardening.
And Andrew, we have a question that was just submitted, perhaps for our BCA panel of experts. It's from Vic, and he's asking, how can a tech tell if a bearing has been case hardened, and what is the difference in hardness between the inside and outside surfaces?
Well, this is Mark Tarrant again.
Thanks, Mark.
Yeah, so essentially you would never be able to see with your naked eye if something was case hardened. The pictures you see right now on screen, the bottom picture, you can see how there's kind of like a shell around the part. Well, the reason that's evident is because there's an acid etch treatment which is used so that way we can measure the thickness. But to your naked eye, you'd never be able to see. And the difference in the hardness between the case hardened layer and the through hardened part can vary depending on application. It can be anywhere from 20 to 30 points on the hardness scale difference, which can have a huge effect if let's say the part was in fact if that distance was closer, like let's say they were only 5 points apart, that could potentially make the part too hard, or if it was a soft application, it could be too soft, and like you were saying, cause excess wear.
Thank you, Mark.
Thank you, Mark. Yes.
So let's move on to the next step in the assembly line. Let's talk about the finish. This is critical because the finish of the Raceway, it's almost a mirror-like finish. You can see yourself in it. And this is done because it needs to have the least amount of friction possible. Because once you start having marks and machine marks in there, what that does is it increases the friction between the two rolling elements and the Raceway itself. And just keep in mind, it's just like a brake system. Friction equals heat, and that heat causes damage. Not just to the Raceway or the ball bearing itself, but it also causes damage to the components, like in particular the lubrication inside of the bearing. So the hotter a bearing runs, the greater the chance of oxidation of the lubricants inside. This means they're basically turning into that sludge that goes in there that doesn't lubricate the bearing very well. So if you're able to control the temperatures by controlling the finish on the Raceways and the ball bearings, that bearing's going to be around for a long time. And most of all, you're going to have lower rolling resistance, which increases the longevity of the bearing. And sort of another side benefit, you're going to have a higher load capacity because you're able to control the temperatures. But this is a very critical thing to understand, that the friction, or what engineers call tribology, determines essentially the temperature of the bearing and the wear rate too. So the better the finish, the lower the friction, the longer the bearing will last. So let's start talking about the rolling elements. We're going down our assembly line right now, and they're going to start using the rolling elements and rolling those into the bearing itself. The most critical thing to remember is they have to be uniform. Once the ball size starts changing from one to the other, this is where you run into a lot of problems. It's critical that they're the same because when you change ball size, you're changing how the bearing is loaded and also the geometry too of the bearing surfaces. So it's critical that they're essentially the same size or very, very tight tolerances between the two to make sure that the loads are evenly distributed on the races of the bearing. And uniformity, it's the sign of precision manufacturing. So to kind of give you a perspective on this tolerance, we talked about this in the introduction, 1 micron. There shouldn't be a difference of 1 micron plus or minus for the bearings inside of a aftermarket hub unit or a Gen 1 bearing. Put this in perspective, that's 4 zeros, 0.00004 of an inch. And a red blood cell is 5 microns across, so very, very tiny. And your hair, it's anywhere between 30 to 50 microns in some cases. But this variation in load, well, it's going to hurt the longevity of the bearing. It's going to fail a lot sooner. Okay, we're down a couple more stations on our assembly line. We start looking at the cages. Cages are essential. I mean, you may think that they're made of plastic, so they're not that important, but what they do is they help to keep the rolling elements properly spaced inside of a bearing. And this means that the bearings are evenly the loads are evenly distributed. So another thing that it does, it also makes sure that the grease inside the bearing is properly distributed. And it just ensures the geometry of the bearings and how they work with the raceways. So it's essential that these components are able to last a long time, withstand very wide ranges of temperature without breaking down. So what happens if you have a poor cage, a poorly made cage? Let's say a little bit of a tolerance is off. Well, what happens is you get more than one rolling element carrying a load in a certain area. So you have 2 bearings, 2 rolling elements, 2 ball bearings. When that happens, you're hurting the efficiency of the bearing because it will have more rolling resistance. So it's critical that that cage keeps the rolling elements properly spaced. Okay, we're almost at the end of our assembly line. We start looking at the seals for a wheel bearing. And these are critical for the life of the bearing because they keep the grease in and the outside contaminants out. And another thing to remember, temperature change. When the temperature changes, the pressure changes inside of the wheel bearing. So if a bearing goes from hot, it's pressurized. In some cases, when it cools down, there can actually be a vacuum produced inside the wheel bearing. So it's critical that that lip is able to seal under those different conditions. And also the finish on the hub itself. This is critical so the lip can properly seal. So almost getting there. We're assembling the bearing. We've got our rollers, we've got our races, we've got our cages, and we're getting ready to make these into the 3 different styles of wheel bearings that you're going to see at your shop when you install them. So let's get talking about those 3 different styles. Basically, how it's broken down is between a Gen 1, Gen 2, and Gen 3 are the number of flanges. So a Gen 1 bearing doesn't have any flanges, so it's the first generation. It's a cartridge type wheel bearing. I don't really like these too much. Installing these, it's a lot of labor to put it into a knuckle. You can see they're press fit. Requires a lot of labor and a lot of tear down. The preload, well, it's set by you at the shop, making sure that you have the right torque on the axle nut. In these bearings, well, one of the seals might have an encoder ring, and it's critical that you get the orientation properly so it's near the wheel speed sensor. And also, when you're pressing it in, making sure that the air gap is correct. Because if you don't get the air gap correct, it's a little bit too far or a little too close, you can cause issues with the ABS system. And all of a sudden, you have a vehicle that didn't have an ABS problem before, all of a sudden it does. So if it's not close enough to the head of the wheel speed sensor, you could have a weak signal, you could have signal dropout, and in these cases, you got a code, unfortunately. So there's only one chance to really get this right, making sure that you have that ring properly orientated towards the wheel speed sensor during installation.
Andrew, we have a question that came in for you and or our panel. Nate has asked the question, what is the best way to detect which seal has the encoder ring? Who'd like to take that?
This is Mark Tarrant again. I'll take that question. So I get this question a lot because a lot of times somebody will have a car, they're up on the hoist and they're getting the ABS signal and they can't figure out what's going on. And it's because they typically, like you had mentioned, they installed it the kind of backwards. The seals do look identical. You can't tell by the naked eye in most situations which end has the encoder. So a nice little trick is to just use something as simple as a paper clip, because the encoder is magnetized. So if the paper clip clings to the seal, that's how you know which side has the encoder. Now, I have also, in a couple different situations, had somebody, they used a screwdriver, but they didn't realize they used a screwdriver with a magnetic bit in the end of it. And they got basically a false reading thinking, oh yeah, well here's where the encoder was, when actually it was on the other side. So just be careful not to use anything that is already magnetized when you're doing this test.
Really smart tip, Mark. Thank you. Good stuff.
So let's move on to Gen 2 wheel bearings. A Gen 2 wheel bearing, well, it basically has one flange, and that's typically mounted on the outside. With these, you're still setting the preload in some cases at the shop. In some cases, there's some certain amount of forming on it to help keep the preload on it. But for the most part, you're preloading these at the shop with the axle nut and either the axle going through or the end of the CV joint. And then Gen 3, this is kind of a neat thing that I was just told this, was that this actually has two flanges. So you have the flange at the front, but the flange at the back, it's designed a couple different ways. It can be pressed on. It can also be orbitally formed, which is kind of a neat way to do it. But these are just about all Gen 3 bearings are going to be wheel bearing hub units. So orbital forming, it's kind of a neat process that they've come up with to help set the preload at the factory. And what this is basically they're taking part of the end of the wheel bearing and they're rolling over a lip onto the outer raceway of the wheel bearing. And what this does is it sets the preload for the bearing. This is a very precise process, and it's typically a cold forming process. And with these, it's a lot of force and a lot of engineering because you're going for, tens of thousands of preload on a bearing, and it requires some very special machining. And it's a very exacting process, and we're seeing more and more of these on more and more applications coming from OEMs. So with these, you could have a platform that has an all-wheel drive and a front-wheel drive model, and still use the same rear wheel bearing. It can differ depending on the manufacturer, but they'll have the same one, and you'll see that hole through the center of the wheel bearing and no axle in it. And you may think something's wrong with the vehicle, but in actuality, that's just an orbitally formed bearing. So let's move on to sensors and sensing. Wheel bearings do not get the credit they deserve because the data or information coming from a wheel speed sensor is used not only by the ABS system, it's used by stability control. It's also used by the ADAS system. So we're talking lane departure. We're even talking systems like Ford, the smart parking system that's able to parallel park the vehicle. Wheel speed sensors have become very exact to measure little tiny movements of the wheel. And this is a thing with the active wheel speed sensors that when you're replacing a wheel speed sensor, you're touching a lot of the safety systems on the vehicle. With these, it can either be a tone ring or an encoder ring, either between the two raceways or on the outside of the bearing on the inboard seal. But it's critical. If you have a wheel bearing, you pull it out of the box and it has a wheel speed sensor in it and it's connected to a long harness, do not remove the new sensor from the wheel bearing and put in the old one because you don't want to reroute the wires from the typically behind a very crusty wheel well or fender liner or on another piece of the vehicle or where the connection is made. Why? Well, it's not just because of the health of the wire. It's because that air gap for that sensor, it's set at the factory. And when you decide to take that shortcut of reusing the wheel speed sensor, and you've destroyed that air gap and how it was set. So that's critical. So don't take that shortcut. Make sure that you're using the sensor that came with the wheel bearing, and don't remove it because you're changing the air gap. And again, I can't stress this enough, if you're dealing with a sensor that is on the vehicle, make sure that you're removing that sensor head so it will not be damaged when you're removing or installing the bearing. I've made this mistake probably 3 or 4 times to where I'll get the job going and I'll say, I can't damage it. And when I'm removing the wheel bearing hub unit, unfortunately, I'll damage that wheel bearing, the ABS sensor. So this is kind of interesting. This is a great thing I learned from the engineers at NTN is how do you measure the quality of a wheel bearing? You can't see inside. They can't see inside. So at the factory, how do they know that they're making a high-quality component? Sure, they got x-rays. They've got other machines that they can use to help for quality control. I mean, they've got to measure the outside tolerances. But how do you know what's going on inside? And their procedure for doing this, it's kind of neat. It's called starting torque or breakaway torque. And this is where they measure the force required to get the bearing moving and starting the rotation. So this test is very involved. It's not just pulling the bearing offline and then measuring it that way. There are steps to make sure, moving it back and forth 10 times in a certain direction, a certain amount of degrees, to make sure that the results are accurate and repeatable. So this is what they're checking inside. And it brings up an important point. It's measuring the interaction between the rolling elements, raceways, seals, and cages inside the bearing, which are very, very critical. And the more consistent it is from one bearing to the next, it's a sign of precision and tolerances that are taking place in the manufacturing process.
Andrew,
so I know
Andrew, we have a question that came in on this slide on the starting torque, and for our subject matter experts as well. Larry wants to know if a replacement bearing needs a lot of force to turn. Is it let me start over. Larry wants to know if a replacement bearing needs a lot of force to turn. Is it a sign of a bad bearing? If it needs a lot of force to turn, is it a sign of a bad bearing?
This is Mark Tarrant again. I'll answer that. Not necessarily. It's typically whenever we're doing any type of testing where we are measuring the starting torque, there is a preparation process that's involved to make sure the numbers are accurate. Sometimes, in some cases, especially if a bearing has been in a box and sitting on the shelf for a little while, potentially the grease could settle to one side or another, and that extra force you're feeling is essentially just the grease needing to be pushed. So what I recommend doing is just try rotating it a few times. Get maybe like 10 revolutions in, and then if it's still very difficult to turn, then that's potentially a sign that there's an issue. But once again, it all depends on the application. some applications have a higher starting torque depending on, the size of the balls and many other factors. So.
Thank you, Mark.
Great information.
Go ahead, Andrew.
Thanks. So I'm just going to wrap this. This is our last slide in the presentation. And the question I always get asked, how does this apply to me? Since you can't really see inside a wheel bearing, understanding what we've gone over between the metallurgy, the rolling elements, what it takes to manufacture a wheel bearing, I'm kind of hoping that this information can help you be able to better diagnose a bearing. If grease is coming out of it, if it's a replacement that happened all of a sudden that to a wheel bearing that was replaced, that you're able to understand what hardness, brittleness, and even some of the damage that can occur out in the field. Hopefully this will help you to be a better technician, to better diagnose a bearing, and to hopefully make the right call when you're selecting or ordering a wheel bearing. That's all I got. This has been
Andrew,
wonderful.
Yep, it was wonderful. Many thanks for this great presentation, and many thanks to our expert panel from NTN's Automotive Aftermarket Division for BCA Bearings, which included Mark Gorski, Manager of Product Management, Mark Tarrant, Application Engineer, and Divjo Singh. Stay tuned for some additional questions. In a few moments, we're going to start the Q&A. So before we do that, I'd like to ask everyone to please take a few moments to fill out our survey. The survey should be popping up on your screen momentarily. If it doesn't launch, you can click the survey icon in your toolbar at the bottom. So please take a moment to answer those questions. That would be very helpful. So now let's answer some of our audience questions, and we received a number of them, and we received this question from Stephen, and he asks, what makes a better cage, metal or plastic? Who'd like to answer that?
This is Mark Tarrant again. I'll take that question. So, in automotive applications specifically, we want to use polymer cages. It's a very special polymer that's used that is a low friction and high heat resistance material. When you're dealing with a metal cage, which are used in more industrial applications at times, you're just introducing more metal on metal contact than is necessary. And even though there is grease lubricating, you want to cut down on metal contact. So long story short, polymer is superior in automotive applications.
Great. Here's another question from Dan, and he asks, are today's factory rim size and low tire profile affecting wheel bearing life?
I'll take that one. Definitely, because there's less of a cushion or less sidewall between the road and the rim itself. So it is causing issues with the wheel bearings taking a little bit more abuse. Because what happens typically when a vehicle hits a pothole is the rim, it can't flex like a sidewall. And this causes damage to the wheel bearing a lot more readily than if there was a nice thick sidewall on a vehicle with a 70 series tire and a 15-inch rim.
Okay. And then we have a question from Paul, and he asks, what makes a ball bearing less resistance than a tapered roller? I'd like to take that.
Mark, I'll leave this one up to you.
Okay, this is Divjo.
Oh, go ahead, Divjo. Take it away.
Yep. Hey, no worries. This is Divjo Singh from NTN. So for the ball bearing, the main difference with the roller would be that you have a point contact with the raceway versus the roller, you have a line contact. So whenever you have a line contact, you have more friction. So that would be the main difference, and you'll see heavier or more friction with the roller bearings.
Okay. Thank you. A couple more questions, and then we'll wrap it up. We got a question from Robert, and he asks, What is the best way to handle a Gen 1 wheel bearing? Press off the car or press on the vehicle? Who'd like to
I'll
take
kind
that?
of start off on that answer.
Go ahead, Andrew. You jump in.
It depends on the application of the vehicle. Typically, some of the kits out there, they're great for installing the bearing on the vehicle with a lot of, it can avoid some of the disassembly of having to remove the knuckle from the vehicle. But in some applications, in my experience, there's no other option than to actually remove the knuckle from the vehicle.
Okay, and thank you, Andrew. Another question came in from April, and she's asking about the preload. Is the preload the same as positive or negative clearance? Anybody?
Yeah, this is Mark Tarrant again. Oh, go ahead.
Good, Mark.
Go ahead, Mark. You answer that.
Okay, so the preload, it would be a negative clearance. Well, it would be a negative clearance because you're essentially putting the load on the part. You wouldn't want to have a positive clearance in a preload application.
Okay. Thank you. Here's one more question here, from Dan. What are some of the more common wheel bearing failures that are not the fault of the bearing?
I think Mark was talking about this before, the alignment of the vehicle, poor installation. Any other ideas?
Mark?
Well, sometimes also if a bearing is subjected to hitting potholes or hitting a curb at a high rate of speed, it can definitely cause accelerated wear. Like something may wear out a lot faster, essentially because upon hitting the curb or the pothole, you're denting the raceway, and now all of a sudden you're introducing potentially contaminant material into the grease, because that any dent or anything that occurs in the raceway is going to start to get worn down by the balls or by the rollers or the ball bearings, and so it's hard to necessarily determine if it's specifically from an incident where you hit a curb or not. But a lot of times when you see something that's wearing out at an accelerated pace, it's usually been abused by the driver, or potentially, like Andrew had said, an alignment issue. Alignment issues, I think, are one of the more common scenarios where you have premature bearing failure.
We're going to continue to answer some additional questions. We're just having a lot of engagement here, so let's just continue to answer some more questions. Have one from Lewis, and he asks, in wheel bearings, how do you know the amount of grease necessary and time for a grease refill? Who'd like to answer that?
I can answer that. This is Matt Gorski, the product manager. Gen 1, 2, and 3 hub assemblies and bearings are non-serviceable, which means they're sealed for life and they do not require re-greasing. If it's a tapered cup and cone or a bearing and race, that's a different story. Those are Gen 0s, which is a different topic than what we're covering today.
Got it. Here's one from Doug. When installing flange mount bearings, is torque sequence important?
Well, I can answer that one too. If you're talking about the 4 bolts or 3 bolts that attach it to the knuckle, the answer is there is no important or star pattern. It's just that you make sure that you seat it fully and flush up against the knuckle. So there is no official torque sequence like there is on a wheel or a flywheel or anything like that.
Thank you. Bob asks, how does improper torquing affect the load? Who'd like to take that one?
I'll take that one, and the engineers can hopefully, if I make a mistake, please interrupt. But basically what you're doing when you're adjusting the preload of a bearing, no matter if it's taper roller bearing or ball bearing, you're adjusting the geometry of the bearing in line with the raceway. So if it's too tight, it means that the bearings are not riding on the right surface of the raceway. Too loose, again, the geometry is not correct between the rolling elements and the raceway.
Thank you, Andrew. Thank you. Well, that's all the time we have for our Q&A session, and I really appreciate the audience participation. It was really terrific, and I'd like to thank our sponsor, BCA Bearings by NTN, again, a product developed specifically for the automotive aftermarket. So this concludes our webinar, and we thank you for your time, and have a great day.